If you think about one of the most important things in humanity right now is the story of climate on our planet. And plants are the living records of climate. So it's almost everywhere you turn, there's a story of plants and change and climate and people. So the story of fossil plants is the greatest untold story on the planet, I think.
Paleobotany is the study of ancient plants. It gives us a way of looking at a very big environment. It is the clue that lets us understand how systems change dynamically, and that is important to us when we are observing so many changes in our own ecosystems today. Plants are usually some of the more pioneering species. They were some of the first things to come to land. They were some of the first things to change the very nature of our planet.
But despite this, it's harder for people to really connect with plants or to get the same kind of excitement that they might have for animals or other subjects. Of course, I was a fan of dinosaurs when I was a kid, and I mean, I still like them, but I also think they're overrated. And so the more I learned about plants, the more I decided, there's so many more mysteries here for me to work on. Like, I should study that. That's awesome. One of the things I really love about paleobotany is all the different kinds of things you get to do.
We are Wyoming because in southwestern Wyoming is famous for petrified wood, especially in the area they call Eden Valley. Like there's many sites that people want to come and dig. We are going to Wagon Bay Formation. I hope to find some petrified wood there at the site if possible.
So finding the localities is one thing, scouting around. The other part is actually digging them out of the ground, which can sometimes take days or weeks of poking around in different places, collecting from the surface, and bringing out lots of tools and bringing up giant pieces of fossil wood and all kinds of different excavation.
And in this case in Wyoming, the sites that we're looking at where we dig, it's lake environments. So you've got shale, you've got sometimes fish fossils, you've got all kinds of different clues about that past environment that's associated with the wood itself.
Oh yeah, that was the end.
That's really good. That limb is really good.
Like at Big Sandy Reservoir, you've got palm stumps that are in place where they grew, and they became mineralized there. But so, for example, the Blue Forest, you've got limbs that are all tangled up. And so the process of how the wood got there and then became mineralized is different.
And so that adds to the knowledge of what did the environment look like and how were things growing. And then lastly, how are things evolving? In other words, you might find early versions of something that evolved into something that's more modern. And museum collections are much larger than what's on exhibit. Maybe only 3% is on exhibit, and many of these collections have never been looked at.
For this project, we focus on the Wyoming Specimen Notebook kept in the museum, especially the 3 museums in the US for natural history. So if we do research, we have a better understanding and we have more story that museum can also bring to tell people and show in the exhibit. So it's just like we try to tell the missing piece of the jigsaw. We try to put jigsaw together.
What we're trying to determine here is there enough preservation to make it worthwhile to study? And almost every piece I've touched here is going, yeah, there's like this piece, yeah, there's enough there to study.
We use a hand lens to see whether or not there is wooden cell structure preserved. When we bring it to the lab, then we start to cut the rock. We select the best preservation and we bring them to cut in the cutting machine.
And then we take it to the microscope that has the light coming from the bottom, shining through the slide, and really started getting excited because then you can start identifying the features and making notes and then going to databases and saying, okay, I got these features. And you go, oh my God, I know what this is.
We will compare the fossil with the modern wood. We need our 3 sections to be able to confirm what family and what genus of species we found. Each taxon have their own unique feature or character. For example, let's say in Wyoming, in the past we see like cinnamon family, so it helps us understand that Wyoming climate back to 50 million years ago, there was a tropical forest and it's quite different from what we see now. One of the favorite moments that I remember is when I look at under microscope and I see the 50 million year old fossil smiling at me through the eyelids. So I feel like that is a great moment that I don't expect to see the oldest smile ever.
It's art. It's beautiful, and when you find it well preserved, and it just kind of almost explodes at you as you get it into focus.
We should build a gap and connection between amateur, senior scientists, citizen science, and the young kids, and also like bridging the gap for like collaboration between researcher and amateur.
A recent outreach program was in the Wind River Indian Reservation in Wyoming. So I worked with the Tribal Historical Preservation Organization. They are the group that mainly helps facilitate how the tribe is able to use the land in a way that helps preserve the culture, but also allows it to be used by the tribe in a way that benefits their communities. Grandma, one of the elders, she explained to them that their way of treating it is, this is evidence that life has been here flourishing for a long period, and that is part of what their culture is trying to preserve. So to them, finding the fossils was very often something of discovering a long history for their land. And while working with them, I recommended a small project that would take the students to the field so they could carry out a real fossil dig in a site that has been long forgotten because it is in tribal land.
And first you show them what to look for, and they start picking up pieces of petrified wood. And then the next step is you give them hand lenses and you show them that there's structure there. They brought up all kinds of things that they had found that they wanted to show me.
That's cool. That's the best one found all day.
I think sometimes scientists and amateurs get so focused on what it is that they want that maybe they don't stop to think about, well, you know, this fossil site is a part of a community. And I think that's why Dr. Boonchai's vision is so good, is because she's not leaving anyone behind. And she's trying to look at this from a multifaceted approach and saying, how can, you know, we make fossil wood sites more valuable to everyone involved?
There would be so much information that would never be known without paleobotany, and so it's really important that more folks get interested in paleobotany because there's just so many questions and so few people to address those questions. So one of the first places I'd look is local museums, see if they have any opportunities for you to get involved in either digs or museum opportunities. You might be surprised, you may not think there's a lot of fossils in your area when there actually are tons and you're just not aware of them. Some of my research has been done on fossils from parking lots. So you can find fossils almost anywhere, even if you don't expect it.
Ben, I just hope that with my career, I can help each local region have a new generation of the fossil wood expert that can lead their own community. And then what we do is just like We collaborate. It's beautiful when we're able to collaborate people from different fields together and make something better.
So if everyone can gather together, no matter how old you are now, no matter where you are, I hope that we will just like move forward together with our boundary.